The next one is the solubility of ferric hydroxide would be maximum in. So it's the question based on solubility, and this ferric hydroxide FeOH taken twice will undergo ionization in water to give Fe3 plus 3OH minus. Now, when you want to check the solubility of this ferric hydroxide in 0.1 molar HCl, it's an acid. It is 0.1 molar H2SO4, once again acid, 0.1 molar H3PO4 and 0.1 molar HClO4. So we need to find out the solubility of ferric hydroxide in these acids, taking each case separately and compare the solubility will be maximum in what? In that case, what we need to check. So here there is an equilibrium between undissolved ferric hydroxide and dissolved or ionized ferric hydroxide. There being an equilibrium between dissolved solute and undissolved solute. The solubility of the ferric hydroxide increases if the equilibrium shifts to the right hand side. And to make the equilibrium to shift the right hand side, one of the substances from the product side should be removed. Since we are taking the solubility of ferric hydroxide in an acid H+, this H+ combines with the OH minus, forming unionized water, and thereby the equilibrium shifts to the right hand side and solubility increases. Thus, solubility of ferric hydroxide is more in acids than in water. But options given are all are acids. HCl is an acid, that is strong acid. Sulfuric acid is a strong dibasic acid. 0.1 molar is a weak tribasic acid. 0.1 molar HClO4 is a strong one. So more the concentration of this H+ ions in the solution, the more is the shift in the equilibrium to the right side and more is the solubility. Therefore, more the concentration of H+ in the solution of an acid, more OH minus will be taken away from the system at equilibrium and more is the shift in the equilibrium to the right side. And the more the shift in the equilibrium to the right side, more is the solubility. That is, now we have to find out that in which of the following four solutions the concentration of H+ is more. Since the case A, if we take into account, HCl being a strong acid undergoes complete ionization to give H+, and since the concentration of HCl being 0.1 molar, the concentration of H+ is also 0.1 molar. So in A, the concentration of H+ is 0.1 molar. But when you go for B, sulfuric acid is a strong dibasic acid. So we need to know that, and undergoes ionization completely to give 2H+ and sulfate ion. Therefore, every 1 molar sulfuric acid will give 2 moles of H+. But the concentration of this H2SO4 is how much? 0.1 molar. So what will be the concentration of H+? This will undergo total ionization to give 0.2 molar H+ ions. So in the B case, that is sulfuric acid case, there are 0.2 moles per liter. Then what about C and D? In the case of C, we have 0.1 molar phosphoric acid. No doubt, phosphoric acid is a tribasic acid, but it is a weak acid. Therefore, do not undergo complete ionization. Hence, though we write H3PO4 can undergo ionization to give 3H+ plus PO4 3-, this is possible only if this could have been a strong acid. Therefore, we don't get 0.1 molar H3PO4 will not give 3 moles of H+. And further, Ka2 and Ka3 values of phosphoric acid being very, very less, the concentration of H+ from this 0.1 molar phosphoric acid will be definitely less than 0.2. So to calculate this, we need Ka2 and Ka3 along with Ka1 of phosphoric acid. As it is the question to compare, we can take it for granted that 0.1 molar H3PO4 will have the concentration of H+ much less than that obtained from 0.1 molar sulfuric acid. Therefore, it is to be taken as less than 0.2. While that of 0.1 molar perchloric acid, if you take into account, perchloric acid is one of the strongest acids known. So in aqueous solution, it will undergo ionization completely, one-sided equation. So we get 1 molar H plus and 1 molar Cl minus for every 1 mole of HClO4. But HClO4 is only 0.1 molar. Therefore, H plus also will be 0.1 molar. So thus, if we compare the H plus concentration from HCl, H2SO4, H3PO4 and HClO4, we find it is 0.1 molar sulfuric acid that undergoes complete ionization to give the H plus concentration of 0.2 molar. Since the H plus concentration is more, it shifts the equilibrium in this system considerably to the right hand side, and thereby more and more amount of ferric hydroxide will dissolve. Thus, the answer is B, but not A, C and D. So, the question is based on solubility involving equilibrium systems.